Really sorry. There was some student's parents who came up without notice, so I have to attend him. I'm really sorry. 1 minute. We'll start first with the specification, and then we will go on to your first lecture. Okay. In today's class, we're going to start with circular motion. 1 minute. Let me just open the file that I have sent to, I think, all of you except Safia. I think I forgot to send you this file to Safia and Tashti. I'll send you guys this after this class ends. Okay. Now, this has a list for all the topics we're going to understand in Unit 4. Then obviously in Unit 4, you have three chapters. Chapter 5 is about further mechanics and mainly it's about kinematics. Okay. It will have momentum in first section, and in the second section you have circular motion or centripetal forces, basically about forces again. Even though in this case you do not need the Newton's first law, third law, second law, but these are again quite needed to understand these concepts. So I would suggest all of you have proper understanding of the three laws for Newton's. Other than that, if there is any confusion, obviously we can solve that within the class, no problem. And again, one thing, as this is kind of in the middle of this Jan 25 batch, so we are entirely done with all the things over here. Right, this momentum is already covered up, but nothing is missed. All the lectures, all the classes are recorded for momentum. So you guys will have to complete the entire momentum recordings within this week, because I think this is the last week for May, and after that we're going to start next month. So I would suggest to complete the entire momentum within this week, and maybe in that case, on next week Friday or Saturday, I provide an extra hour for any of the problems you have from the conceptuals of momentum. Okay, and after this again, we are going to solve few worksheets. There will be two worksheets on further mechanics. Also, one thing, in this week also we'll continue with our classes, right? So in as a homework, you guys have to watch the recording for momentum, and as a classwork, we guys will start with circular motion. Like today is our first class for circular motion, and then again there will be next classes on Wednesday and Thursday, right? So on these two classes, we can complete the entire circular motion in this week. Circular motion is not that much lengthy or not even that much difficult. I think compared to momentum, circular motion is quite easy and doesn't contain that much of topic. For momentum, it was quite lengthy and have a lot of things to understand and do the calculations for. But circular motion is entirely about calculations, and they might ask you few relationships between between radius and forces. Other than that, they don't have even that much derivations or relationships. Only very few theories will come up from circular motion. Other than that, nothing that much important. And then again, after every chapter, we're going to solve two worksheets. Now, in these worksheets, like first one will contain 20 to 25 questions. This is the worksheet that we will do in class. Like I'll complete all these questions in class, and the second worksheet will be a homework. You guys are supposed to solve this as homework and then submit a PDF in our Google Classroom. And another thing is, for our homeworks, obviously there will be points where you would find it confusing or difficult to answer. So we will leave you problematic questions and we will solve your problems from the homework in an again extra hour. No, we are not going to use our class time to solve problems from your worksheets. Okay, these will be solved in extra classes. I'll try to keep the extra classes on weekends so that it doesn't clash with any of the other classes you guys are attending at the moment. And after this, we're going to have one exam. And one thing, the exam will not contain any questions we have completed in the worksheets. So, I mean, it will be in the same pattern, but it will contain different questions from the questions we did in the worksheet. So, you guys obviously have to go through the worksheet, recover from the topics where you think you are weak at, and after that, you move on to your exam. Okay, every exam will be at least of 80 marks, because in your A levels, Unit 4 is entirely of 80 marks, right? The raw paper is of 80 marks, and that will begin converted to your out of 120, where they will scale your marks to give you the UMS marks. And similarly, after that, we have electric field. I'm not going to change the content serial thing in your book. In your book also, there's first explaining kinematics, then electric fields, and then after that, particles. So nuclear particles, we are going to follow that also. Okay, I'm not going to change the pattern. Everything is actually serially organized, so I'm going to follow that pattern. We are obviously completing chapter 5 first, and from July we are going to start chapter 6, and then from I think the entire July, from June, entire June I will the entire June it will take me to complete chapter 6. Chapter 6 is quite lengthy because it has electric field, capacitors, and then again electromagnetism. For your book, I think electromagnetism only has like three sections: magnetic fields, electromotive induction, and after that maybe some applications for these concept, maybe AC motor and transformers. The problem is that only these three topics are not involved in like magnetic fields or electromagnetism. A lot of things are involved. These are all the topics which has to be memorized or understood for this chapter, section 3 for chapter 6. Okay, all of these things, we cannot miss out any this from any of the topics from this list. So that is quite a very big content. I would actually take like it would actually take for me to 6 to 7 classes to complete all these lists for just electromagnetism. So I'm considering that for electric field I would actually need entire June and half of July, and after that the rest of the half of July will be needed for chapter 7. Chapter 7 is quite small, so it won't take more than 8 or 9 classes. Okay, chapter 7 won't take more than 8 or 9 classes. And that is also the maximum amount of class that I'm saying, but it might also take less classes than that. And another thing, in chapter 7, it is quite related to the last section of chapter 6. For example, in chapter 7, we'll again learn about cloud chambers and cloud chambers and cyclotron. Those things will be explained in detail in magnetic fields. So that is, they are quite related. So that's why they are. I would suggest doing these chapters serially. First magnetic fields, and then go on to atomic structure. So now this is your content. Another thing I wanted to explain is like syllabus completion in that process. For example, now in May, or last week of May, we are in the last section for chapter 5, right? So within May, I'm going to complete chapter 5 entirely, and then on June and July. Within these 2 months, I will complete chapter 6 and chapter 7. Chapter 7 would take like the last 2 weeks of July and the first 2 weeks, and in entire June, we will complete only chapter 6, all of the electric fields, capacitors, and magnetic fields. After that, we'll move on to unit 5. This is going to start from August. We're going to start unit 5 from August. So August, September, and October. These 3 months, we are going to start like complete entirely unit 5. And also, I'm not going to just hang on unit 5 within these 3 months. We cannot stop unit 4. So we have to complete unit 4 question papers within 3 months. So what I will do is that for August, September, and October, I mean, we are having 3 weekly classes, right? We are going to use 2 classes for our unit 5 concepts and 1 classes for your unit 4 question paper. I will obviously complete one question paper entirely from A to Z, and then from the next days, you guys are going to complete the paper, and we'll solve your problems within that class. And obviously, you guys have to submit your paper into the Google Classroom, so I can check your answers and see if something was properly written or not. For example, for MCQs, I cannot actually check anything. For MCQs, I just have to check the points that if you chose the right answer or not. Other than that, MCQs doesn't have to be checked, but for that written answers, for the star mark questions, I have to check your writing pattern, right? So that's why you'll have to submit your files also in our Google Classroom. Like after completing 2019, you have to take a PDF or make a PDF of the entire copy and then submit the copy in our Google Classroom. So in August, September, and October, I'm also considering the entire of like half of November. In November, 2 weeks. We are going to use 2 classes for Unit 5 and 1 class for Unit 4. This is for QP solving. And I'm actually exaggerating entire content over here. We would not actually need all these total month to complete Unit 5. Unit 5 is not that much lengthy, it's quite short. And I'm also expecting that within these months, we can start Unit 5 question papers also. Like, for example, the week of November, we can start the question papers of Unit 5. Okay, then let me just rearrange this 1 minute. And this would be a proper writing that for August, September, October, 2 classes for Unit 5 and 1 class for Unit 4 question paper. And then from November, we're going to start Unit 6 also. I'm going to start Unit 6 from the first week of November or second week of November. So we're going to take 2 classes for Unit 6 and 1 class for Unit 5 question paper. Okay. And obviously, Unit 6 question paper are not that much lengthy. I mean, you guys have did Unit 3, right? Unit 3 and Unit 6 both have like 4 questions in each paper. And I'll obviously solve at least 2 questions of Unit 6 entirely in classes. So you guys would have to just then, for the rest of the paper, do your homework and send in your problem. As I've already stated that they have only like 4 questions in each paper, so I can actually solve like 3 years or 3 papers in one class because 4 questions or solving 12 questions in an 1 hour 30 minutes class duration is not that much tricky, right? So for December now, and again for November also, we're going to start our Unit 4 mocks. Okay, from November, we can start our mocks. So this is going to be mocks for Unit 4. We're going to start the mocks for Unit 4 in November. And from December onwards, we're going to start the mocks for Unit 5 and Unit 6 mocks. Our exams will start on January. Basically, Unit 4, 5, 6, I think they will start from like January 15th or something. So from January 15th to whatever the time duration is, you guys are going to be provided with like extra tutorial hours. I mean, we're not going to get any scheduled classes in January. Our entire batch would end by December. But if there is any problem in some question papers or we want to solve like one last time few question papers, I can give you some repeated question papers list. For those kind of tutorials, we are going to have few extra classes in the entire January month. Okay, so that will be not entirely scheduled. That will be like extra classes that I can provide, as much extra classes I can provide. And then again, there will be like 3 fixed classes before your exams. For example, before Unit 1, we're going to have a class. Before Unit 5, another class. And then again, before Unit 6, we're going to have our last classes. And other than that, we're going to have 5 mocks for each unit. And if we have more time, you can complete or try to complete more mocks than that. Okay, so this is it. And again, question papers for that list, we're going to solve at first. We're going to start solving question papers from June 2020 to the last year that is available. For example, for Jan 24, so Jan 25, October 24 would be available, right? So these are the question papers we will solve from June 2020 to October 24. And if by that time we have completed all these question papers for these past 4 years and we still have more time left for our November, December time duration, class duration, in that case, we'll start moving backward, like from 2018, 19, 20, all these years. Okay, start moving backward. I don't think that moving beyond 2016 is necessary because even 2019 and 16, those 3 years are from your old specification. So old specification is not like that. Old specification is entirely different, but they have few different question pattern. For example, in new specification, we use the word resolution more other than precision, right? These type of wordings are changed from old specification to new specification. Other than that, the question pattern is quite similar. Solving more conceptual questions will only enhance your understanding about physics. So I think that if we have more time, we should go back to the back, but not beyond 2016. Up to 2016 is possible or is should be applicable. Other than that, other questions in 2015, 13, 14, they're unnecessary. They're not that much relevant to the topic you're going to be asked in your A to B specification. And then again, we have Unit 6. Unit 6 have again uh, 8 core practicals. So it will not actually take much more time to solve those 8 core practicals. Because core practicals, I mean, this is entirely theoretical over here, right? For Unit 6, this is entirely theoretical. You are not going to be asked to do perform an entire experiment in the exam hall. This is not Cambridge in Excel. You just have to explain that why meter ruler should be used, why ICT or that video camera should be used, why we should use data logger or ticker tapes, right? In order to minimize your percentages of error and minimize the uncertainties and increase your overall accuracy of the result, right? These are the things we'll be understanding in our Unit 6 classes. Other than that, all the 8 core practicals that you will actually come across will not that much be, like for Unit 6 actually, they don't actually ask questions from the like core practicals entirely. For example, in Unit 3 also you saw that we do the first 8 core practicals, but in your exam hall, they don't actually ask questions from your core practicals. They ask questions from like basic understanding. Maybe use a protector, how to use a protector, how to do uncertainty calculation, how to do normal uncertainty calculation, and how to find out that which particular material is made up of either aluminium, bronze, or copper. Right? These kind of questions will be asked in your exams. Not exactly the core practicals we will do. But then again, I think core practicals are needed because for your core questions from Unit 4 and 5. Because in questions for Unit 4 and 5, they will obviously ask you one question where you have to describe one method of carrying out an experiment. Okay, experimental description will be asked in Unit 4 and 5. That's why I always suggest don't sit for Unit 4 5 separately other than Unit 6. Sit for the A's entirely for 1, 2, 3, and then again for 4, 5, 6. Some people want to do Unit 1 separately, but that is not recommended because Unit 1 has these few resolutions which we taught in our Unit 3 classes. Similarly for Unit 6 and 4 also. I mean, the core practicals you're going to get from Unit 6 are actually taken from Unit 4 and 5. For example, I have the list for core practicals over here. These are the core practicals for A2. For example, the first core practical, relationship between force exerted on an object during exchange of momentum, that is Unit 4, right? And then use of IC2 to analyze collisions. This is again Unit 4, Chapter 5, momentum. Using oscilloscope or data logger to display and analyze the potential difference across a capacitor. This is capacitance, capacitor from Unit 4, Chapter 7. So again, Unit 4. And then calibrate a thermistor to potential. This is again Unit 4. And determine the specific latent heat of phase change. This is Unit 5. This is Chapter 8 of Unit 5. And then investigate the relationship between pressure and volume. This is also Unit 5. Absorption of gamma radiation, Unit 5. And determine the value of unknown mass, resonant frequency, Unit 5. Okay. As you can see that Unit 6 does not actually contain anything new content. All the core practicals you're going to see, we're obviously going to discuss this in detail in our Unit 4 and 5 classes. Okay. Similarly for Unit 3 also, Unit 3 and Unit 6, they do not contain any other content. They are just basically few topics taken from Unit 4 and 5 or 1 and 2, and they have just compiled an experiment out of those topics. Other than that, if there is any question. Mm. Okay, Nihal, is there any problem from your side? We'll actually start after the prayer. Okay, just wait for minutes.
No, ma'am.
So, I was asking, is there any questions? Sure, Tanisha, no problem.
Okay, miss, thank you.
আর নিহাল, তোমার কোনো কোয়েশ্চেন আছে এখান থেকে?
না ম্যাম, এটা মানে প্র্যাকটিক্যালি যেটা বুঝতে পারছি, কিন্তু ওই যে মানে ইউনিট গুলো মানে ইউনিট 4 থেকে আর ইউনিট 5 থেকে কি প্র্যাকটিক্যাল আসবে মানে ইউনিট 6 এ?
হুম হুম হুম।
আচ্ছা
মানে তুমি হয়তো বা এটা কনসিডার করছিলা যে ইউনিট 6 will contain entirely new topic. That is not the case. I mean, in
আচ্ছা
unit 6 you will learn nothing new, right? All the things you have studied in unit 4 and 5, only from those topics they will have selected few experiments from unit 4 and 5, and that is compiled in your unit 6. Other than that, nothing new.
আচ্ছা ম্যাম, ওই যে যে বইটা মানে আমার কি বই কেনা লাগবে ফিজিক্সের জন্য? আমার কাছে পিডিএফ আছে, আমি বই কিনিনি তো এখন, মানে স্টুডেন্ট বুক ওইটা কি কেনা লাগবে?
Student bookটা actually খুব helpful না. The student book actually contain, I mean, they don't actually contain all this stuff in general. Like the Pearson edXL student book 2 you're talking about, that is not that much helpful. So we will actually do few questions from the student book also. For example, at every chapter end, they have this exam pattern questions. Okay, I think that is exam 1 or exam 2, labeled as exam 1 or exam 2. We will solve those questions on only. So I think for only solving those questions, you do not need to buy the entire book. You can solve that entirely from the PDF version also. No need to buy the book.
আচ্ছা আচ্ছা
Okay. And again, other than that unit student book 2, they have this lab book also available for unit 6. Similarly, for lab book also, it's quite, I would say, useless entirely because lab book contain nothing that is going to be asked in your exam paper. Okay, unit 6 এর জন্য তোমার যে বইটাই ফলো করো, even if you're following the student book 2 or the lab book, they will not ask any questions from either of the books. You just have to complete question papers entirely for unit 6. Unit 6 এর জন্য question paper ছাড়া there's nothing other than that is good to actually practice from. Only question paper is useful for unit 6, and other than
আচ্ছা
that nothing.
আপু, কোশ্চেন পেপার বলতে কি আপনি পাস্ট পেপার বুঝাচ্ছেন, মানে পাস্টে যে এক্সাম গুলো হয়েছে ওই পেপার গুলা?
Right, হ্যাঁ.
আচ্ছা
We indicate question paper as the past papers.
আচ্ছা
Huh. And similarly, over here, the worksheets that I'm going to create after every chapter, the chapter-wise worksheets I'm going to create. This is not entirely new. I'm not going to make these question papers. These question papers are actually going to be taken from your past papers. Okay, from 2016 to 2020-21. I will try to make the question papers from the older papers, like these worksheets. I'll try to make these worksheets from the older paper, so that by the time we're going to start our year-wise question paper, we can solve the unsolved papers. For example, 2016 to 2000, uh, at least 2020. Okay, these questions, like questions from these past papers, will be taken to create worksheets, and which we will obviously solve after the end of each chapter. And from 2020 to 2024 October session, these papers will be solved as a year-wise session. So that what happens is that you're going at the end, by solving the chapter-wise question papers or also solving the year-wise separately, you have actually solved all the questions from 2016 to 2024 onwards. Right? So you guys are not going to miss anything. Short papers is solved here from 2016 to 2024. So other than that, another thing, we are going to solve, like we're going to do 5 mocks, at least 5 mocks for 3 units, right? For these 5 mocks, they are not going to contain any repeated questions. That means the 5 mocks that I am going to create, they are going to be entirely handmade, and they will not contain any questions taken from 2016 to 2024. Yes. Thank you, Tanisha, for informing me. As I was saying, that the mocks over here will not be any questions taken from your past paper. The mocks will contain entirely new questions. So I would suggest prepare well for your mocks. Don't waste the papers, because these 5 mocks are going to be like 5 different sessions for exam for you, because they will contain entirely new concept, nothing from the older questions we have solved in the past papers. So try to focus entirely on mocks, or try to prepare well for mocks. Just don't come to the mocks without zero preparations. Okay. Okay, other than that, there's nothing else to explain now. I'll move on to your classrooms and let you guys see that how the classroom is. For example, for your Jan 2025 A2 classes, that is not entirely organized yet because we haven't uploaded that much of content. For Jan 2025, only this momentum and class slides and specifications are there. We're going to start with circular motion, so that will again be uploaded. But other than that, if I go back to my like previous classes, for example, this batch, we started this one quite earlier. So for this ACE October physics, we have completed a lot of things. So I could arrange this class very neatly, I would say. For unit one, they have all these topics we have completed, and for all the topics, there will be like 4 to 3 sections. So, for example, we are going to give you PDF notes. Okay, if I go to this file, this is their PDF notes. Wait 1 minute, yeah. This is their PDF note. That is basically everything that, for example, small definitions that come across in Unit 4, Unit 1, those will be attached in these PDF notes. And after that, after the PDF notes, they have every class slides. Class slides means that whatever I'm going to teach in the class, I will actually write on the board, right? So all those class slides will also be provided. This is their class slides for Unit 1, Lecture 1. Similarly, for you guys also, all the class slides are added in your classroom, and other than that, the class recordings. Okay, these are the class recordings for that topic entirely. So this is how we're going to sectionize every topic on your unit 4, unit 5 also. Okay.
Uh, ma'am,
Yes.
ma'am, I'm not added to the Google Classroom.
Yeah, you guys, this is actually a trial class. I was actually thinking that do this class, then you decided to want to join my classes or not. Right.
Oh yeah, I'm sorry.
Okay, no problem. Okay, then this is your classroom. I think we can start with our classes now. This will be a little bit extra lengthy class because I want to solve entirely of like half of circular motion in today. Okay, so I'm sorry. Wait. We're going to start with circular motion lecture one. We did that previously for the other people. For Safi, I think you did this already, but I'm going to explain circular motion again for one last time. And this is going to be a little extended version. We're also going to introduce equations, also equations and derivations for everything in terms of circular motion. So Safia, please attend. Just don't leave the class. Okay. Now for circular motion, in ideas or basics from our AS, right? We could only calculate things if they were only linear. For example, there's a particle at position A, and by the time maybe like after 5 seconds or 4 seconds, the same particle would travel and reach position B, and this is the time taken for 4 seconds. Okay. And then again from position A to position B, the time taken was 4 seconds. Maybe the initial velocity that they have provided was 0 meters per second, and velocity over here at the final stage, final velocity was maybe 5 meters per second. And the equations you would use to find out these change in position, to find out the acceleration, that was going to be V minus U over T. Problem is these equations, the equations of motions, and then normal equation, that was what constant velocity equation, p is equals to d by t. All these equations could only be used for your linear cases. Okay, let me just write, like make a chart of this for linear kinematics and for angular kinematics. So we are going to start with angular kinematics. Circular motion is actually about angular kinematics. Also, one thing, all the slides that I am going to write over here in addition to the other than the class PDF, you guys would also have to write these things on your copy. Okay, I'm obviously like giving you guys this class PDF for better understanding, or maybe in some classes you might not be able to take these notes right with me in the class. So you can take that after the class also. So I'm providing the class slides for your benefit But don't take it as a otherwise option that okay, she's providing with the class slides. Let's not write these things on our copy. I'll directly learn from those class slides. So I would suggest write all these things with your on your copy. And again, after every month, like at the end of every month, I would ask for the PDFs, like make a PDF for the entire copy and then send it to me, like so that I can check that you guys are actually writing all these things with on your copy. So if anyone fails to do so, I'll stop uploading the class slides. So linear kinematics, the things we studied in our AS, and Angular is the one that will be assessed in your A2. Okay, some things obviously will be related to your AS concepts, but now we're just going to like modify the equations. For example, in linear kinematics, the equations were for constant velocity, the equation was v is equals to d divided by time, right? Now in angular kinematics, for again the same assumption, constant velocity, the equation that we're going to use now over here is v is equals to 2 pi r over t. I'll obviously explain that how we are getting 2 pi r over t. But these are actually the derivations of the equations. Okay, so this is how I'm going to write it, and after that I'll again explain this to you exactly how I'm getting this. But then again, this has its name. This is known as tangential velocity. In angular kinematics, we are going to have like two types of velocities. One is this tangential velocity, and another one, there will be another one, which is angular velocity. And that is represented with omega or kind of W. And this is just what? 2 theta, sorry, not 2 theta, theta by time. Okay, this is your angular velocity formula. I'll explain again in detail how we are getting this, but I'm just writing all the lists so you can identify that these equations are derived in terms of theta, in terms of pi, in the angular situation. For example, over here in acceleration, for constant acceleration equation, for constant acceleration, for constant acceleration, you would have used the equation s equals to, a equals to v minus u divided by t, right? That was the assumption or equation that you would have used for constant acceleration. V minus u over t. This time for your angular acceleration, since now you have like what? Two types of velocity. So now you can again write an angular acceleration in terms of two types of velocity, in terms of tangential velocity and in terms of angular velocity. So the two values for your acceleration are v square by radius, or the other one would be radius omega square. Okay, either of them can be written. I'll again explain how we're actually getting all these things value. And then lastly, for force, equation was F equals to ma on the linear kinematics section. And in angular kinematics sections, now we're going to have F equals to mv square divided by r, and then F equals to m r omega square. Right? These are the two types of acceleration or two types of force that you're going to get only because you have two types of velocity over here in angular kinematics situation. Now we can clearly see the equations are not similar anymore. The equations are entirely different, right? They have these angles involved, omega, which is a very new topic for us. And other than that, pi is also sometimes involved. I'll explain why, how, and exactly pi comes to this equation. But let's start with our first understanding. From our A's, not from A's actually, from our IGCSEs, we understood that, for example, an object over here is moving in a circular pathway. There's an object at this point. This is maybe at point A. Okay. At point A over here, the object starts its journey with constant velocity. But the basic understanding, I think all of us, we know that at constant velocity, acceleration is zero, right? I think I should write this down over here. Constant velocity indicates the value for your A is 0 meter per second square. Okay. Now, at constant velocity, obviously acceleration is zero. That means there will be no change in acceleration. If the magnitude of your velocity is not changing, in that case, acceleration should be zero. But over here, if the object is moving with constant velocity along the circular pathway, the acceleration should change. And exactly for what reason the acceleration should change, we were not able to answer that or explain that for our IGCSEs or for AS. We only explain this in this way that acceleration is a vector quantity and so is your velocity. Right, velocity is also a vector quantity. And because of that, as velocity is a vector quantity, obviously depends on both, right, magnitude and direction. Depending on these two criteria, it means that either of them, if either of them is changing in the entire journey, that would cause the entire velocity to change. Over here in this example, the object was moving with constant magnitude of velocity along this entire circular pathway. That means magnitude was constant over here, right? This is constant, but in this direction, for a circle, it doesn't have any constant direction. For example, for a circle over here, at point A, it was traveling in this direction. Okay, again at the next point, then it would travel in this direction. Then again for this point, it would travel in this direction. Then over here in this direction. But as you can clearly see, at every point, at every second, the direction of this circular pathway changes. So if your direction is not constant, according to our AS or IGCSE basics, we would say that the direction was changing. And because of this change in direction, velocity changes. And if velocity changes, acceleration would also change, right? So according to that basis, we would explain that, okay, if the entire circular pathway doesn't have a constant direction, in that case, change in direction causes the velocity entirely to change. And as velocity, like acceleration is dependent on velocity, if there is a change in velocity, there will be a change in acceleration. The acceleration is now no longer constant. It is now going to change over here, right? That is our basic understanding from our IGCSEs or AS. Is there any problem from this explanation? Any questions from this part?
Ma'am,
Mm-hmm.
uh, I forgot what omega stands for. Can you please tell me again?
You forgot what? Sorry?
I forgot what omega stands for.
I'm really sorry, I cannot hear you clearly. Can you please repeat again?
Ma'am, what does omega stand for?
Oh, omega. Omega stands for angular velocity. Okay. I will
Okay.
explain that again. I mean, I don't expect all of you to understand that. These are the things that is not are not explained yet. Okay. I've only give you the list over there so that you can identify the differences. Other than that, I'll explain this to you a little bit later in today's class, but a little bit later.
Okay, ma'am. Thank
Okay,
you.
omega otherwise stands for angular velocity. Okay. Now, other than that, if there is any questions for this section, today's understanding.
No, ma'am.
No. Nihal, is this clear for you?
Yes, ma'am.
So now as we're going to move on, this entire explanation, the change in direction causes velocity to change and this indirectly causes the acceleration to change, right? This entire thing is only applicable for your linear kinematics. Like this explanation was good, was perfect, but this is again only applicable for linear kinematics, not for your angular kinematics. Okay, this is only applicable for linear kinematics. Now, what happens in your angular kinematics? In angular kinematics, now obviously in terms of angle, you are going to measure everything, right? Change in direction now will be measured in terms of angle. So we can now actually find out the direction change because now we can measure the angles. In linear kinematics, we were unable to measure the angle, but in circular motions or in angular kinematics, we can now find out the angle. Now, for circular motion, what happens? We have to first find out is actually, why would this particular car or cart, whatever the object is that is positioned at point A, would travel along this circular pathway. That is because at every situation, there is a center seeking force acting on this particle. Okay, so I'll just write erase. Oh, no, I don't think, yeah, I can erase this. Okay. Now I will draw this entire same card at four different sections of the journey. This is the same card on four different sections of the circular pathway, and at every point there will be a force acting on a particle that will act at the center of the circle. And because of this center-seeking force, the particle will be able to travel on the circular pathway. So over here, this center-seeking force, okay, this is known as F subscript C. This is a center-seeking force. And this center-seeking force is known as your centripetal force. Now, we a lot of time we consider that centripetal force is a different type of force itself. For example, in your IGCSEs or in your AS, we learned about few types of force, right? For example, tension, weight, then normal reaction force, friction, thrust, right? Drag, then air resistance, upthrust. These are the few types of force we learned in our IGCSEs, right? Out of those forces, centripetal force was never mentioned. That's because centripetal force is not entirely like a entirely new form of force. This is just a resultant force at the end of when like multiple forces acting on the particle. The resultant force that will be in the center of the circle, that will be directed to the center of the circle, that is known as centripetal force. So many people think that this is an entire new form of force, but this is not a new form of force. This is just the resultant of multiple forces acting on the particle towards the center of the circle. Okay, let me just write down the list of types of forces that act on a particle first, and then I'll explain that what are the forces acting on a particle when this object was moving on this circular pathway. For example, wait 1 minute, types of forces. The forces we saw so far, part A was maybe tension that is present in ropes. Part B is other than tension, weight, right? The gravitational field strength. And then for part C, we can write normal reaction force. I'll just write NRF, okay? Normal reaction force. Then for part D, weight, tension, normal reaction force, we can have upthrust there. For part E, I can write friction, very important force, and then drag, and then air resistance. Air resistance. These are the few types of force we learn in our IGCSEs, right? Now over here, for example, this is a scenario for a car moving on a circular pathway. Okay, so for this car moving on a circular pathway, what are the forces that are actually traveling, or what are the forces that is actually like acting on this car? Not exactly a car on a circular pathway. Let's consider this is like an entire ring, and on that ring there is some card, and you can just move that card on this ring entirely. And this ring is entirely on a vertical plane, by the way. This is not on the horizontal plane. This is on the vertical plane. Okay. So there's a ring on the vertical plane, and on that ring, there's a card which is going to travel along the circular pathway. It একটা লম্বা দাঁড়া করানো ring, right? এটা শোয়ানো ring, horizontal plane এর নাই. Horizontal plane থাকলে I would have written that or drawn that in this format. Yeah, this is in the horizontal plane. Okay, so this is not in the horizontal plane. This is like entirely perpendicular to the horizontal plane. I think from this diagram it is quite obvious. Say this is your horizontal plane and this is your vertical plane. On this example, this ring over here is on the horizontal plane. So what are the few forces that will act on the particle while it will travel on the horizontal plane? Obviously, when there is what I mean, at the end of the day, doesn't matter wherever you are, weight will always act on you, right? So over here, if I try to labelize all the forces that are acting on the particle in the vertical plane, which ones will they be? For example, over here, on this particle, point A, this is point A, B, this is point C, and this is point D. Okay. At point A, there's a weight of W newtons acting in the center, and there's a weight of, also not weight, there's a normal reaction force acting on the particle. This is R. Okay, this is normal reaction force and weight. And obviously, as the object is traveling, the ring is not smooth. There will be a friction also. Friction always acts in the backward, in the opposite direction, right? That's why over here it will now act as a tangent. Tangent means that when this line only meets the curve at only one point. So over here friction will act as a tangent in the backward direction. The particle is actually moving in this way. Okay, this was the direction of the particle moving along the ring. So this is the friction. Other than that, if you move on to option B now, this is position B. I'll labelize position B later. This time, weight would continue to act in the downward direction, right? Weight would always act in the downward direction. Weight never acts in perpendicular to the plane or perpendicular to the motion. It will always be in the downward direction. Doesn't matter wherever, on whichever plane you are, weight will always act vertically downward. Not just downward, it will always act vertically downward. But normal reaction force is now going to act perpendicular to the surface. This time, over here now we're going to have normal reaction force, and again in the backward direction we're going to have your friction. If we move on to part C now, similarly weight it will act vertically downward, and this time normal reaction force will also act towards the center, right, perpendicular to the surface again. And this is your direction for your tangent. This is the direction for your friction. Lastly, for point D now, 1 minute. For point D now, again, weight acts vertically downward. This is the direction for your reaction force. And this is the on the upward direction, again, friction acts. Oh, no, sorry, not in this direction. This time, friction and weight both will act in the downward direction. This is weight, this is friction, because now the particle was moving in this direction, right? So friction will act in the opposite direction. Now over here, how can you understand what would be the value for your centripetal force? If I include some values or some magnitudes, it would be easier for you to understand. For example, in this at the top section at point A, right? This is your circle's center, by the way. You have to understand that which force is acting towards the center. You can clearly understand at the top point, weight is acting towards the center. This is your normal reaction force, and this is again weight. Okay. At the top section or at point A, weight was acting towards the center, right? So then I would have considered the weight to be my centripetal force, because of weight, the object was actually directed towards the center of the circle. But then again, not entirely weight was only acting in this vertical plane. Weight will be cancelled out with your reaction force also. So over here, as we know, centripetal force is not a different type of force. Centripetal force is just a resultant of all the force acting on the particle. But at the end of the day, centripetal force means there has to be a resultant force. That means resultant force cannot be zero. There has to be some force, extra force that must act towards the center of the circle. Okay, this is just a resultant force. Which means that if the value for your weight was 50 Newton and the value for your reaction force was 40 Newton, in that case, at the end, 50 minus 40, you are going to be going to be left out with extra 10 Newton of force towards the center, right? In that case, though, that 10 Newton of force will be the centripetal force. Okay. Now, in this case, I can suggest or I can actually rearrange equations for the four sections of the journey. For example, for section A now, for section A, you have resultant force equals to mass acceleration. That's how I would use to write the resultant force equation in A's, but this time I will write it as the different types of forces acting on the particle at point A, which is W minus friction. So not friction, resistance. We have normal reaction force. This is your equation for centripetal force. This time I'm not going to write it as RF, resultant force. Now I will write this as F subscript C, W minus reaction force, right? Whatever the value that you're going to get, that will be the amount of centripetal force acting on the particle at point A towards the center of the circle. Similarly, if you move on to point B again, over here, you can suggest that you can clearly see that towards the center, only reaction force is acting. Other than that, there is no other force in this direction, right? If there is no other force to actually find out in this direction, that means the entire normal reaction force will now act as a centripetal force. So you can now write that point B as resultant force, as centripetal force, as reaction force, and then finally write centripetal force is equals to reaction force. Lastly, for point C again, this is going to be what? Reaction force towards the center and weight is away from the center. As your object always have to have a resultant force towards the center, at this point, now reaction force has to be greater than weight. Okay, this time the reaction force will increase to make this particular object move in a circular pathway. There has to be a resultant force towards the center of the circle. For that reason now, this time, resultant force, it will be no longer equals to W minus R. But previously, at the very top section, we wrote W minus R because in this section, weight was acting towards the center. And always to create a resultant force towards the center, right? Whatever the force that is acting towards the center, that has to be greater. এখানে weight and reaction force was working, right? Was acting on the particle. So to make this weight towards the, like, to make this weight greater or to make this entire resultant force greater towards the center of the circle, that's why we took weight minus R. Because এখানে extra amount of weight থাকতে হবে, weight কে বড় থাকতে হবে, weight has to be greater. Other than that, there will be a resultant force away from the circle. সেটা তো centripetal force হতো না। যদি এই পয়েন্টে আমি রিয়াকশন ফোর্সটাকে বড় ধরতাম আর ওয়েটটাকে ছোট ধরতাম, তাহলে this particular material would be moving away from the center. সেটা কিন্তু আমাকে centripetal force দিত না. For centripetal force, they always have to be a resultant force towards the center. So clearly বোঝা যাচ্ছে, out of these two forces acting on the particle at point A, weight was acting towards the center, right? This was acting away from the center. So in order to make this particle move in a circular pathway, there has to be a resultant centripetal force for which weight has to be greater for section A. And if you move on to section C now, which is basically the opposite of section A. This is top section, this is bottom section. At bottom section, what happens? There are two forces again acting, reaction force and weight. But this time, the reaction force was acting towards the center. That means in order to create a resultant force towards the center, reaction force this time has to be greater. So over here, reaction force has to be greater than weight. So now I will write the equation as reaction force minus weight, which is now going to be the equation for your centripetal force. Reaction force minus weight. Other than that, for point D again, we can only see reaction force acting towards the center and there's no other force acting opposite to that, right? So now again at point D and B, they're quite similar, of like mirror of each other, right? For point D and B, they're entirely similar and mirror of each other. We can clearly see that only reaction force was acting towards the center. So the entire reaction force will now be acting as your centripetal force. So this time we can again write the same equation. Resultant force is equals to reaction force and centripetal force is equals to reaction force. Right? Okay. Other than that, is there any questions from this part?
No, miss.
Okay. Nihal, এটা clear?
হ্যাঁ মিস এটা বুঝতে পারছি।
আচ্ছা। Okay. Then আমরা একটু next টাতে move করি। This is A, B, C, D. Okay, one thing I should write it down over here. For this section, I was considering that weight is greater than reaction force and reaction force is greater than weight. Right. Weight greater than reaction force greater than weight. These are the concepts. Okay. Now, after this, exactly how this react, I mean, different types of forces would act in different concepts.
Should be for C, where you wrote
Sorry.
reaction.
Right. Right, but D it was in the opposite direction, right? Sorry. This is for point C. Okay. Now, after this point, this was for vertical, I mean, for entire vertical circular motion, right? This is for vertical circular motion. I should write this down. And there could be cases for horizontal circular motion also. That means, let's see another example for horizontal circular motion before we move on to the difference of your equations. Okay. Sorry. Now this is obviously on a horizontal plane, but at the end of the day, over here also only your vertical forces are actually acting. Yeah, I'll explain this, and then again after that, I'll provide another example. This is not actually entirely on vertical plane, no sorry. I'll explain this, but these are again in horizontal motion. So I'll just write these things in that diagram under that heading. These are also again vertical motion, vertical circular motion. For horizontal circular motion, this is how we can think about. This is an example. This can be used as the example for horizontal circular motion. Now over here, I think I should have drawn a circle. That would be better. 1 minute. Okay. Now in this case, for example, over here up to this point, there's a car or cart, whatever it is traveling on this circular pathway. As it's traveling on the circular pathway, it was obviously acting in this direction. The forces were acting in this direction in a linear way. If the forces continue to act in a linear way, it will completely move out of the circular pathway. We can clearly see this is how it will move out of the circular pathway. In order to make it move in this bending curvature, like over here, you can clearly see there's a bending in this section. In order to move across that bending section, there are a few forces acting on the particle. For example, ekhane, maybe the forces that are acting is these forces. At this point, there's a forward force from the engine and there's a backward force from the friction. Right? These are the forces acting on the particle. Now, if the forces continue to act in a linear way, কিন্তু কার্ভের বাইরে চলে যেত। In order to make it move in a circular pathway, forward force সেটা change হবে না. It will continue to move in the forward direction, but the friction over here will continue to change its direction. This is your friction, by the way. The backward one was friction, and the সামনেটা হচ্ছে driving force. আমি DF লিখে রাখি, driving force. So এখানে ধর এই পয়েন্টে যখন আসতেছে, এই পয়েন্টে ওর ড্রাইভিং ফোর্স এগেইন ওই যে একদম ফরওয়ার্ডে যা থাকবে, যেরকম আগে কাজ করতেছিল এখনো সেরকম ভাবেই কাজ করবে, but your friction now is acting towards the center. At every point over here, this is your friction that will make the object move towards the center. Okay, that means the next position over here কিরকম হবে, sorry, নেক্সট পজিশনে ফ্রিকশনটা তোমার হচ্ছে এরকম ভাবে যাবে। নেক্সট পজিশন আপনি কারের পুরো ডাইরেকশনটা চেঞ্জ হয়ে যায়, তখন কারটা এরকম থাকে না, তখন কার এরকম ভাবে চলে যায়, তখন ফ্রিকশনটা এইভাবে যাবে, মানে ফরওয়ার্ড ফোর্সটা এইভাবে যাবে, ড্রাইভিং ফোর্স যেটা ছিল, আর এখন ফ্রিকশন উইল অ্যাক্ট in this direction. That is now going to create your centripetal force, right? Every point of friction টা চেঞ্জ হতে থাকে। এই পয়েন্টে ড্রাইভিং ফোর্স এখানে আসে and friction এই জায়গায়। The next situation, driving force is in forward force. This is a driving direction force, and friction is towards the center. So this is the centripetal forces acting on the horizontal circular motion. At every point over here, it is the friction that is changing. And now over here, we can clearly see friction is actually acting as a centripetal force, right? Because in the other three diagrams, there is no obviously other force compensating your value for friction. There is no other force cancelling out the magnitude of your friction, because a direction or in the opposite direction, there was no other force acting, right? Only friction was acting towards the center of the circle or in this plane. Only friction was acting in this plane. That means over here or all the other cases, friction was acting towards the center of the circle. After we have explained the equations, we can come back to this and again understand that why this curving or bending part of your curve should be more wider than that. This is a very narrow curving bend, and we can clearly see it's very narrow over here, and that is quite problematic for cars also. It should be more wider, like less curving it should be. And why is that? Why should a circular pathway on a horizontal motion, why should that be less curved? We will understand that, but after we have explained the equations. Other than that, is there any problem for this circular motion, horizontal circular motion? Hmm. Okay, for Tanisha and Nihal, any questions?
No, ma'am.
Okay. Then we'll move on to these diagrams again. These are specifically named as ditch, and this is named as bridge. These are some extended versions for your vertical circular motion. Now, in these situations, what happens if there's a car on the horizontal motion? Obviously, there's a forward force, driving force, right? There's a backward force, friction, and weight acts in the vertically downward direction, and reaction force acts in the vertically upward direction, right? But this situation, as long as it is in the on the horizontal ground, weight and drag, so weight and reaction force are quite equal. That is also the case for this scenario also on the opposite side. But the problem is when it was at the very bottom of this ditch, in this section, this time the forward force and the friction will not actually play any important role. Over here, your reaction force and weight will now create an important section. This is your weight, and in the upward direction, you have your reaction force. This is your reaction force and weight. At this point, in order to make it move in this direction, right? At every point, the reaction force is acting now as a circle, right? We can clearly see if we have created a circle over here. This is the center of your circle. That means reaction force is exactly the force or centripetal force over here. A reaction force should be greater in this case in order to create a centripetal force, in order to create a resultant force towards the center of the circle. For this situation, your reaction force has to be greater than weight for this extra amount of force acting towards the center. And because of this extra amount of resultant force acting towards the center, the car over here will be able to move up the plane. And then again, when it was moving down the plane also, reaction force was supposed to be greater. For this entire ditch scenario, reaction force at the end has to be greater than weight in order to make it pass through this entire ditch structure, ditch type of canal or structure that is present on road. These are again vertical circular motion concepts. In this situation, the centripetal force would be reaction force minus weight. And again, on the other part or on the bridge situation, similar cases on the horizontal ground, driving force and friction plays a role, and other than that, nothing that much is important. 1 minute. These are the forces. Now, at the very top part over here, this is your top section, right? This is your top section. This is the top of your bridge. At the top of your bridge, obviously, weight is acting in the downward direction, and your reaction force is acting in the upward direction, right? So now over here, reaction force has to be smaller because we can clearly see in this section we're going to create a circle, right? So weight is now acting towards the center of the circle. So always remember, whatever the force that is acting towards the center of the circle, that should be greater in that scenario. So over here, if weight is acting towards the center of the circle, in that case, weight should be greater than reaction force. So if weight is greater than reaction force, এখানে তোমার centripetal force এর equation হবে, the equation for your centripetal force would be W minus R. Right? This is the value for your, or equation for your centripetal force for bridge situations, and that was for your ditch situation. Okay? This is the equation. I mean, we completely explained the total scenario for the circle, but this is like different sections of the circle. Okay. Is there any questions from the circular motion, from vertical circular motion part?
No, ma'am.
Okay. Then we will start with the equations. Like, how can I derive those equations from circular motions? Okay. This is the, wait 1 minute. Yeah, this is the center of the circle. Obviously, from center to the circumference or to this end of the circle, this is radius, right? One radius. This is also another radius. And over here, it's creating an angle of theta degrees. Also, one thing, we're going to find out the angle in its base unit. Okay, I mean, angles can be measured in degrees and in radian. In most of the cases in Unit 4 physics, you will consider measuring the angle in radians, not in degrees, unless the question ask you to calculate the angle in degrees, then only you have to calculate that in degrees. Other than that, always measure angles in radians. Okay. Now over here, you're going to get your first tangential velocity at this point. This is your tangential velocity, and then again, this is your another tangential velocity. By the way, always remember the tangential velocity will only meet the circle only at one point, right? This is how the tangential velocities are created. This is again tangential velocity. Now, for these situations, for your tangential velocities and for your angular velocity, we are going to consider different values. For example, over here, for tangential velocity, I'm going to consider this as point A and this as point B. I can clearly see that for your tangential velocity, the particle is only moving this direction, right? Like this, a small sector of the circle. I can consider this as a small sector, right? OAP is a sector, obviously. So only that small arc length was traveled for the tangential velocity. For arc length, if you remember, the value was theta by 360 or theta by the compared to the total angle multiplied with 2 pi r, right? Now over here, in this situation, the actual AB distance can be measured with that similar concept, arc length formula. Wait 1 minute. Arc length formula was like any arc length. Okay, any arc length formula was theta by, either you're measuring the angle in 360 or whatever you're measuring it with, it will be 360 degree multiplied with 2 pi r. That was the formula for your arc length. And in terms of degrees, right? I think in mensuration IGCSEs, or yeah, in mensuration IGCSEs and in P2 maths, right? I think we learned this type of equations, the calculation for arc length. This is again the equation for degrees. But in most cases, we measure the angle in terms of radians in this physics unit 4, right? So we have to find out the arc length also in terms of radian. The equation for arc length in terms of radian was just r theta. Okay, that was the equation for your arc length in terms of radian. So this is for radian. Now, if I want to find out the value for your tangential velocity over here, I'm going to use the equation. For tangential velocity, I'm going to consider object is moving with constant velocity. Okay, let me just write this down. This is for tangential velocity. Which is considered as constant velocity. Okay, but this tangential velocity now, we can, as it is moving with constant velocity, so obviously I can use my old linear velocity. This velocity is equals to distance divided by time, right? Now again over here, tangential velocity can be represented as distance is what? That highlighted section of the circle, right? That is your arc length AB. So I can write arc length divided by time. And then again, arc length was just what? R theta. So this one again becomes tangential velocity is r theta divided by time. So this is how you actually get your value for your tangential velocity. Tangential velocity for any kind of theta. The problem is if your value of the theta is 2 pi. 2 pi means for one complete rotation, right? If you're going to start from point A and then go back to point A, then you're creating one complete rotation. For one complete rotation, angle is always fixed, 360 degrees or 2 pi. In that case, for one complete rotation, theta is always 2 pi. Wait, sorry, 1 minute. Theta is 2 pi. So in that case, if the value for your theta is 2 pi, I can now write the tangential equation as r. Instead of writing theta, I'm just going to input the value of theta over here. That is 2 pi by t. So I'm going to rearrange and write the equation lastly as 2 pi r divided by t. This derivation is important, very important. Most of the time, you will actually be considered to find out the tangential velocity for the complete circle, okay, for one complete circle. And that's why this is the most common equation that we use. But then we forget that this is actually not the original equation, right? This is only the equation for tangential velocity for one complete circle, for one complete rotation. But this is the original equation for a tangent. Some people forget that, and that's why whenever the exam papers change their angle from 2 pi, they get confused and can understand that where they're going to input the values for theta over here. Over here, the theta was entirely 2 pi over here, right? In this situation, as it was completing one complete circle, so obviously the angle for this one complete circle was 360 degree or theta, or sorry, of 2 pi. So in that case, theta becomes 2 pi. Other than that, this is your original equation for tangential velocity. I would highlight this one. For all kind of other cases, when the theta is not equals to 2 pi, and this one can only be used when the theta is equals to 2 pi for one complete cycle. Okay. Let's zoom out so that you guys can see this entire thing. Read this entire thing and let me know if there is any problem from this part. Again, if you're using these two equations, theta must be in radians, right? Because I obviously did not use this degrees equation to derive this equation. Over here, I'm only using theta in radians. In both the cases, theta is measured in radians. If theta was measured in degrees, in that case, the angle formula would be theta by 362 pi r divided by time. But in that situation, that would be the value for your equation. But then again, at the end of the day, for one complete circle, the time equation should be same, right? The value for your time, the value for your total tangential velocity for one complete circle will be same. For example, if over here, I'll just make a margin and then try to find out the tangential velocity in terms of degrees. That would be velocity, arc length over time. Arc length over here is going to be theta by 360 multiplied with 2 pi r divided by time. Okay. And if the value for theta now becomes entirely 2 pi or 360 for one complete circle, now it will be 360 divided by 360 with 2 pi r divided by time, which makes it clear. This 360 gets cancelled out and gives you with 1 and leaves you with 1. So now you have 2 pi r divided by time. At the end of the day, the tangential velocity for one complete circuit turns out to be same. Doesn't matter if if you're calculating the value of your theta in terms of radian or in terms of degrees. Hmm. Is there any problem from this part?
No.
No, ma'am.
Okay. I'll just keep this thing. This is in degrees. I hope you guys can remember. Wait. I just want to write this thing, but I don't have much space. Wait 1 minute. In degrees, okay? These were in radians. In most of the cases, you will only be asked to calculate the tangential velocity in radians. So these are like quite useless. I mean, on a it ashe. It's very rare to calculate the value for your angle in terms of degrees. I think in your further physics level, for example, in physics 101, 102, you'll be asked to calculate the tangential velocities in degrees. Other than that, in Edexcel, they never asked. I don't think I saw in any paper that they asked to calculate the tangential velocity in terms of degrees, other than in radians. But they do change the value for your theta very often. It's not like J অনেক rarely change করে. In most of the question papers, they change the value for your theta. So try to remember this equation and then derive from this equation, through this equation. এটা সবচেয়ে important equation. Tangential velocity in terms of radian. Okay. Acha, now let's measure the angular velocity. Just copy this circle. Angular velocity is referred to as omega. Tangential velocity এরকম নিজের কোনো নাম নাই, right? Tangential velocity is just tangential velocity. It doesn't have its own name. Now, angular velocity doesn't have its own symbol, but angular velocity has its own name and own symbol. এখানে in angular velocity we measure the difference in angle, ঠিক আছে? So for example, at the very start when it was at point A, the angle was 0, but as it starts traveling from point A to point B, it is now obviously moving away from A, right? And how much far it has moved from A will measure in terms of angle, and angle is again measured in terms of radians over here. So this is for angular velocity. And in angular velocity, it is referred to as omega. This is omega. And let me write this down. Those of you who have A-levels biology, this is nothing of the omega acids we learn in biology unit 2. Okay, this is entirely new, not omega acid. Now over here, omega is actually difference in angle divided by time. Okay, this is actually difference in angle over time, like how much angle how much angle was traveled or how much farther from a point was traveled with respect to time. So angle difference would be basically theta divided by time. And then again, as we're measuring this one in terms of angle, right? This is also one derivations, and over here we can write f is equals to 1 over t, if you guys remember. Uh, why we are referring this circle with waves? If can anyone let me know? Like why we are referring this circle with waves? This is the equation for frequency that we used in our unit to physics waves. Can anyone tell me why we are referring circles with frequency? Tanisha?
Are we considering the whole circle as a wave, like one
Right.
wave?
Right. We are considering the whole circle as a wave because if you remember from your waves theory, 1 minute, 1, 2, 3, 4. In that case, the waves were something like this. This is how a wave looks like, right? Complete wave, one complete wave. Now from this one complete wave, if I take these sections, they obviously create almost a circle, right? I mean, over here I also used autocorrect classic complete circle create highlight. Like they do resemble your shape of a circle. Right? This is the top half and this is the like bottom half. Over here,
Is it about superposition, like destructive interference, or you just um, theoretically doing this?
no, I'm not considering this for destructive interference or constructive interference. Interference is not there. Okay, not here. I'm just like showing this that why we are using frequency over here for circular motion because frequency and for was for waves and waves can be combined together to create one complete circle. It has nothing to do about interferences or anything.
Okay, I'm sorry.
No problem. um, interference and what was the other thing? Superposition, right? Interference superposition is not related. আমি just এখানে interact করতেছি যে why am I using frequency in the case of kinematics? That is because moving in a circle is basically like moving on a wave. So that's why we can connect that 1 over time with frequency. Moving on a circle, like তুমি এখানে circular path move করো or on this wave, both are same. At the end of the day, you're going to travel the same distance. So এখানে now with this sound since we can now write the time 1 over time as frequency. So this was the equation 1. I can now like derive this equation over here as omega is equals to theta by t. This turns out to be omega theta 1 over t. Right, 1 over t now can be expressed as frequency, which turns out to be omega theta f. Okay, now then again, this is your basic equation for angular velocity. But again, for one complete circle, the value for your theta turns out to be 2 pi, right? So if the, I should write this down, for one complete circle, theta turns out to be 2 pi. If the value for your theta turns out to be 2 pi, in that case, omega would be 2 pi f. This is again the second most used formula for omega or angular velocity, 2 pi f. But that is only applicable if the value for your theta is not anything other than 2 pi. Okay, is there any questions from this part?
No.
Understanding এর পার্টটা এতটুকু ছিল, like this is only the section 2 understanding part for angular velocity, for tangential velocity. Other than that, now we're going to derive the value for your acceleration I mean, that's just we're going to use the equation for your angular velocity and um, tangential velocity to get the value of your acceleration. Other than that, I'm an extra কিছু use করব না এখানে। আচ্ছা, before that, before we move on to your tangential, I mean acceleration, I can actually interact my tangential velocity with angular velocity. Over here, obviously moving in a circle, now the particle has two velocities, right? Either it's tangential or angular. But at the end of the day, both of them are connected to the same particle. It's like projectile motion. In projectile motion, we saw we have horizontal and vertical motion, but at the end of the day, only one particle within one time it was traveling two different motion, right? It was having two different motion. Over here also, at the end, only one particle moving on the circular pathway will have this angular velocity and tangential velocity. So obviously they are connected to each other. Like in projectile motion also, horizontal motion and vertical motion, they were independent to each other, but they would obviously take the same amount of time to travel two different distances or two different motions. Over here also, they both will take the same amount of time to travel at two different velocities, angular and tangential. So this is a one very important relation or derivation. Okay, this is between tangential velocity and omega. So let's start with tangential velocity's equation. Tangential velocity's equation was, I will consider that as, so it was pi theta by t, right? From this part I can write, so it was pi, sorry, this was r theta by t. I can write r theta by t separately, and theta by t itself was your value for angular velocity. Right? This portion was angular velocity. And now in the next time I can write angular velocity. So tangential velocity is actually r omega. And this is one of the derivation which is very commonly asked for 1-2 marks in your exam papers. Relationship between tangential and omega. In unit 4, so my most of the things will be derived. Like every equation has to be derived with other equation, has to be related with any other equation. So derivations and equations are very important for unit 4. Ingla repetitive জিনিস. Like if you can memorize these things also, you will get at least 15 marks out of this. 15, not 50, okay? 15 marks out of this from each paper. So easy 15 marks, right? So 15 marks maybe was a greater value. 10 marks you can get out of these derivations. So relationships between angular and the velocity omega. So now we'll move on to acceleration and force formula. Again, since now you have two different equations for velocities, so obviously there will be two different equations for acceleration also using those two different velocities. So if you're going to use v is equals to r theta by t, in that case, your value for acceleration turns out to be, this is actually v square r. This is the value for your angular velocity, v square by r. Now using this, you can actually find out your value for acceleration in terms of omega also. For example, v square can be broken down as, I'll actually write this as r omega. Okay. In that case, a is equals to r omega square divided by r. If you break down that square from the numerator, you're going to have r square omega square divided by r. So this r gets cancelled out, and now you are left out with r omega square. So this is the value for your acceleration. Okay. Either you can write in terms of v square by r or r omega square. And if this is the workings or equations for acceleration, you can just input this into your calculation for force also. Originally, the normal equation for force was F equals to ma, but now as you have two equations for acceleration, so for Fc now, centripetal force, we're going to have m v square by r, right? And the other equation would be Fc mr omega square. This can be written actually as in a better format. This can be written in a better format, that m v square divided by r. Okay. These are the two values or two equations for your centripetal force. Quite important. Both equations are equally used. So these are both important. So other than that, এখান থেকে কারো কোনো problem? Any questions from this part? Any problem from anyone?
No.
No, ma'am.
Okay, now this is the end. I'm not going to explain any more things. আমরা just একটা part একটু back করবো. We need to go back to the horizontal circular motion because of these equations. Okay. Now from this equation, specifically from this derivation, I can clearly see that radius is inversely proportional to your centripetal force, right? And if radius is inversely proportional to your centripetal force, you go back to this diagram and now see এখানে যতটা less curvature থাকবে, হ্যাঁ, on a circular pathway. Less curvature means at a smaller radius, right? আর যতটা wider spread হতো circleটা, the way most widespread the circle is, larger radius. For a smaller radius, obviously a larger centripetal force has to be provided. Now over here, only friction was acting as a centripetal force. So for this situation, if the maximum amount of friction is not equal, like is not actually enough to cover up that large centripetal force, now the entire cart will move away from the circular pathway. So that's why in cases for those hill tracks where they actually have to use this bending curvatures, right, around the mountains. So for those cases, we try to extend the curve as more as we can so that the radius actually increases from the center of the mountain to the curvature. If the radius is large, in that case, according to your equation, the equation was if mv square over r. For a larger radius, centripetal force has to be smaller. And if the centripetal force is smaller, that means a smaller friction is now entirely enough to provide you with the centripetal force to make this cart move on the circular pathway. So that's why in horizontal circular motion, it is related to the radius of that circle, right? The larger the circle, the smaller the centripetal force, or vice versa. The smaller the radius and larger the centripetal force. Is there any question from this concept now?
No, ma'am. No, ma'am.
So I'm sorry for extending this class entire for almost 2 hours now. Most of our classes won't be actually of 2 hours. Okay, আজকে কিছু একদিন আমি পড়াবো না। আমরা এখানে I will write down the routine for you guys. For your A2 Jan 25 routines are actually একটু change হয়েছে. There has been a small change in the routine. The routines are going to be on Monday, Wednesday, and Thursday. Timing is same. Timing is supposed to be 1 p.m. Okay, I'll try to finish the classes by 2 p.m. Okay. So these are your E2 Jan 25 physics class timing. Monday, Wednesday, Thursday, 1 to 2 p.m.
Ma'am, I might have classes on Mondays and Wednesdays.
Okay, then wait 1 minute. Wait one. Okay, you can do a class on Monday and Wednesday at from 2 to 3. Is it fine?
I'll try my best to join at 1. If it is not possible, then I will join at 2. I will let you know, ma'am, on WhatsApp.
Okay, can you let me know why by tomorrow. Is that fine?
Sorry, ma'am. Can you please repeat?
Can you let me know by tomorrow?
Yeah, okay, ma'am. I will just call my other teachers and
Okay.
reschedule with
Okay,
them.
okay, then so far this is the final timing. If Tanisha doesn't have any problem, then we'll stick to this. Okay.
Okay.